this is Sung, and I'm the Principal and Director of Sky Academy, and we've been looking at linear functions, and in particular we've been looking at the different forms that linear functions can take. Okay? And we've been looking at three forms in particular: the gradient intercept form, the point gradient form, the 2-point form, and now we're going to look at another form called the general form. Alright, now let me just start by saying this. The most common form and the most useful form for graphing a straight line is the gradient intercept form. Okay, y is equal to mx plus b, because it tells us the most information off the cuff about how to graph the function. It tells us the gradient, and then it also tells us the y-intercept. Right? When it comes to solving or using algebra with linear equations, the general form is often very useful for us. All right, the general form, but it's not very useful when it comes to graphing. So the reason why we're doing the general form is to help us with the algebra. And I guess the main skill that you'll have to know with the general form is how to convert between the general form and the gradient intercept form, and the gradient intercept form and the general form. So I'm going to do a couple of examples with you, but let me go through what the general form looks like. The general form looks like this: ax plus by plus c equals 0. And what we want to see happen is we want all of the terms plus the constant term on the left hand side equaling 0. So we don't want anything, we want to bring everything over to one side, and on the other side we have 0. Okay? And not only that, so we've got the x term on the left hand side, the y term on the left hand side, and we've got the constant on the left hand side. The other thing that we want to do is, with the general form, a, b and c need to be whole numbers. We want a, b and c to be whole numbers, and we want a to be positive. Right? A is usually positive. So in other words, the term for x is positive. Right? And we want the general form to be in its simplest whole number ratio. Okay? So there's three things. Let me just write them down for you. We want a, b and c on one side, a, b and c to be whole, a to be positive, and we want a, b and c to be in simplest whole ratio. So they're the four things that need to be the case for the general form to work. Okay? So let's have a look at this particular question. Express in general form y is equal to half x plus 4. So that's in gradient intercept form into general form. So we bring everything over to the left hand side, and we've got minus a half x plus y minus 4 equals to 0. Alright, so that's just by bringing everything over to the left hand side. This and this, when we move it across, need to change signs, and that's why that's the case. Needs to be whole numbers, so let's multiply by 2. Let's multiply by negative 2 in fact, and so we get x plus 2y, and it's not plus 2y, it's minus 2y plus 8 equals to 0. Does that make sense, what we did? And then we need to observe, is the coefficient for x positive? Yes, it's positive. Yes. Is it in the simplest whole number ratio? Yes, it is. Okay. So an example of it not being the simplest whole number ratio might be, say this, 3x minus 6y plus 24 equals to 0. See how we can divide everything by 3? And that would give us a simpler whole number ratio. So that would be a a better expression of the general form than this would be. Okay, so there we go. So the answer is x minus 2y plus 8. Let's have a look at this question here. We need to do the same thing. We can start by bringing everything over to the left-hand side, or we can bring the y over to the right-hand side. And so we've got 3/4 x minus y minus 2/3 equals to 0. Okay? Yeah. Or 0 equals 2, but that's still equal to 0. Yep. Now, is x positive? Or is the coefficient of x positive? Yes, it is. So we don't have to multiply it by a negative number, but what we need to do is, let's work out what we need to multiply everything by to bring everything into whole numbers. All right? And you've got a denominator of 4 here and a denominator of 3 there. The lowest common multiple will be 12. So let's multiply everything by 12. 3/4 of 12 is 9x minus 12y minus 8 equals to 0. Okay? So we've done that by multiplying by 12. We've done that by bring y over. Okay? Yep. And so that is the process of moving from from gradient intercept form to general form. Okay? Now we've also got to be able to work the other way around. So we've got an equation here that says express the gradient intercept form, express the general form into gradient intercept form. So to do that, we've just got to make y the subject of the formula. We just need to make y the subject. Okay? So bring the x term and the constant term over to the other side, and we've got minus 5y is equal to minus 2x minus 1. Alright? We can multiply everything by minus 1 now. So it's 5y is equal to 2x plus 1. Yep. And then divide everything by 5. Y is equal to 2/5 x plus 1/5 plus 1/5. Okay? And that will be the general form. Okay, and we did that by dividing everything by 5. Divide the y term by 5, we get y. Divide 2x by 5, which is 2 on 5x. Divide 1 by 5, which is 1 over 5. And that form tells us that the gradient is 2/5, and the y-intercept is 1/5. Does that make sense? And so that's why we need to convert from general form to gradient intercept form, because it helps us to graph the functions better. Okay? Because once we're in this form, we can easily graph the function. Okay? So this is called the general form. They're the 4 forms that it would be great for you to learn. Alright? And then in the next episode we'll be looking at some other stuff, alright, to do with straight lines. There's plenty more to go, so stay in tune for the next couple of episodes. Thank you very much for watching.